Welcome everyone, and this will be a demonstration of my final year project. So the system is comprised of two main parts, to which it consists of the PV system and the irrigation system. The PV system is started by turning on the battery disconnect and then turning on the PV panel disconnect. The battery currently has 12.5 volts. There's no load on the system right now. Currently generating 13 volts at 0.2 amps. The load for the irrigation system is turned on by pressing the enter button. So firstly we have the PV panel here, outdoors, generating power. This power is then sent to the charge controller here. The charge controller then decides how much to charge the batteries, to which the batteries are then charged. The charged batteries are then used by the irrigation system here, which is controlled by an Arduino Uno. So the irrigation system works such that the moisture level is measured by the capacitive moisture sensor probe. So once the soil moisture is above 60, the irrigation valve would be off, stating that okay, the soil is moist enough, there's no more irrigating to be done. And once the soil moisture is less than 60%, the irrigation valve would turn on, hence stating that the soil needs to be watered. So then we move along to the system which supplies the water. So here we have a water tank represented by the cup of water. So the water tank level is measured using the ultrasonic sensor, to which the tank is then filled by a DC pump in the reservoir. So the reservoir would take the water, fill it to the tank, and then supply the plants with water. The tank is at 40%. So if I were to use this object here to vary or manipulate the height of the water, you can see the values changing. So I would go up with the device in my hand here. I can see the values changing on the screen. So if I go up to 50%, so I went up to 50%, to which the DC pump comes on, indicating that the tank is filling, and it stops filling at 95%. Another main part of the project is the TH11 sensor, to which it measures the humidity and the battery bank temperature. So I will now manipulate the temperature, to which I increase it using a hairdryer. When the temperature increases over 35 degrees, the red LED for the battery bank turns on, and the ventilation fan as well turns on to cool the battery bank. So as you can see, the ventilation and cooling fan turns off at 35 degrees. The humidity sensor is also used to predict the weather conditions using this LED. So the LED is red at the moment, indicating that there is a high chance of rain falling, to which the humidity is at 72%. So then we have a small demonstration as to how the floating PV would work. So then we have the floating device, to which it will be placed on. It has a lot of ventilation for the PV panel. So then the PV panel will be placed on top there, to which it floats and generates power. So there we go. That is a brief introduction as to how the system works with the various sensors and components of the system. Thank you for your time.